Imagine someone hands you a glass of crystal clear water. They tell you it didn't come from a bottle. It didn't come from a well. It didn't come from the city water supply. It didn't even come from rain. Instead, they tell you it came directly from the air. Would you drink it? For many people, the first reaction is skepticism. How can air become drinking water? Can something invisible really produce clean water? Or is it simply another technology making promises that sound too good to be true? These are reasonable questions. After all, drinking water isn't something most people are willing to gamble with. Water affects health, safety, and everyday life. That's why understanding where water comes from is just as important as understanding how it's treated. The surprising part is that the atmosphere around us already contains an enormous amount of water. The challenge has never been finding it. The challenge has always been collecting it safely. One of the biggest misconceptions is that atmospheric water generators somehow create water. They don't. They simply collect moisture that already exists in the surrounding air. Think about condensation forming on a cold drink during a warm afternoon. Those droplets weren't inside the glass. They came from humidity in the air. Atmospheric water generators use the same physical principle. Fans pull air through cooling components. As the temperature drops, water vapor condenses into liquid. That water is then collected before entering a treatment process. The machine isn't manufacturing water. It's recovering something that was already there. The quality of that water, however, depends on everything that happens after condensation. And that's where engineering becomes extremely important. Collecting water is only the first step. Raw condensed water still requires treatment. Most atmospheric water generators use several purification stages: sediment filtration, activated carbon, ultraviolet sterilization, sometimes additional mineral cartridges. Each stage serves a different purpose. Some improve taste, others reduce microorganisms, others help maintain water quality inside the storage reservoir. Like any water treatment system, maintenance also matters. Filters need replacement. Internal components require cleaning. Poor maintenance can reduce performance regardless of the technology. The machine itself doesn't guarantee safe water. Proper operation does. Understanding this difference is one of the most important parts of evaluating the technology. Every drinking water source has advantages and limitations. Municipal water systems depend on public infrastructure. Private wells depend on groundwater conditions. Rainwater harvesting depends on weather. Bottled water depends on transportation and supply chains. Atmospheric water generators depend largely on humidity and electricity. Rather than replacing every other source, many homeowners use them as one part of a larger preparedness strategy. Some combine atmospheric water generation with rainwater harvesting. Others use emergency water storage, portable filtration, or backup water supplies. The strongest preparedness plans rarely rely on a single solution. Instead, they create multiple options, because resilience comes from flexibility, not dependence. Perhaps the most interesting lesson isn't whether atmospheric water generators work. Modern engineering has already demonstrated that they can collect moisture from the air. The better question is whether this technology fits your own environment, climate, and preparedness goals. Every household is different. Every region has different humidity levels. Every family has different water needs. The smartest decisions come from understanding how each system works, instead of relying on assumptions or marketing claims. The more you understand your available water options, the more prepared you'll be for unexpected situations. Water security isn't built around one machine. It's built around knowledge, planning, and having multiple ways to access clean water when you need it most. If you found this video helpful, subscribe for more content about water preparedness, atmospheric water technology, off-grid living, and practical self-sufficiency. You'll also find additional resources in the description covering atmospheric water generators, emergency water storage, filtration systems, rainwater harvesting, and alternative water solutions discussed in this video. Thanks for watching, stay prepared, and we'll see you in the next video.